Hello everyone, my name is Advait Kauta and welcome back to another episode of Class 8 Geography. Today we'll be covering the second chapter in geography, that is land, soil, water, natural vegetation and wildlife resources. So I've divided this chapter up into two parts for you, so it'll be easier for you to learn. First is part 1, which we'll be covering today, and next is part 2, which we'll be covering in a future video. In part 1, we'll be talking about two things. First is land, second is soil. In land, we'll be talking about land use and land conservation. In soil, we'll be talking about the types of soil, formation of soil, and conservation of soil. So now that we've organized the chapter, let's start the video. Okay, so first of all, what is land? Well, land is basically everything that you see underneath you. It is basically the crust of the earth. Everything that you see in the crust is called land. So, what is the difference between land and soil? This is a very common question. This is not asked in the exams, but I'd like to tell you this for the purpose of your understanding. So, when we say soil, we mean grainy substance. So, the grainy substance that you find on land is called soil. So, soil is found on land. Without land, soil cannot survive. But without soil, land can survive, land can exist. Land can exist without soil, though it won't be useful to us. But without land, soil cannot exist. So land is basically everything that is underneath, whereas the substance present above the land, like right on the land, is called soil. So that's the difference between the two, land versus soil. So never ever use these terms interchangeably because they do not mean the same thing. Okay, so now that we understood what land is, let's look at let's look at another important thing about land. How does land affect population? How does land affect the population of a place? Well, think of it this way. If I'll give you two different scenarios to imagine. I give you some hilly mountains and I give you grassy plains. Out of these two, which one do you think, in which one would you prefer to live? Well, most of you will answer plains. Because why plains? And that is the exact point. Why do more people choose to live in the plains rather than mountains? The reason, first of all, is the topography of the land. What do I mean by topography? Topography का मतलब होता है the physical structure of the land. Topography means the physical structure. The physical structure of the land. Is the land elevated, or is it plain? Is it normal? Is it straight? So that is called the topography. So when the topography is straight, it is easier to build anything. Why do we prefer a straight topography? Is it is easier to build anything. अब आप ही सोचिए, if there's a crooked, if there are these mountains with such tips, do you think it's easy to build a home over here? I don't think so. It's not easy to build a home over there because this tip cannot balance an entire house, can it? So that's why we need plains. We need plain areas where it is easier to build. So that's our first point. That is topography. What is topography? Topography is the physical structure of the land. Second when we talk about is agriculture. In places like plains, agriculture is easy because the lower, so I'll show this to you. For example, these are mountains and these are plains. water is flowing, let's say here. That's the water table somewhere at this level. It's not this close, but let's say it's here hypothetically. Now, I have built, let's say somehow I've cut down this part of the mountain and I've built a residency here. Is it easy for me to access this water? No, I have to dig very, very deep to access this water if I want to perform agriculture. For agriculture, you need water. So I have to dig very deep to reach for the water. Whereas in plains, I only have to dig a very, very small amount of land in order to get to water and other natural resources. And that is why people settle for plains, because it's easier for me to reach whatever is inside the earth. So things like coal, petroleum, all of these, especially water, become extremely easy. So that is the main reason, and that is the main way how population is affected by land. It is affect. So if the land is a plain, if it's plains, then there is more population. Plains attract a higher population, whereas mountains don't. Mountains do not attract a large population because of the reasons that we saw: topography and access to natural resources. So uh, that is how land affects population. The second thing that we look at when we talk about land in this chapter is, what is land use? I don't mean what is the use of land. I mean, what is the meaning of the term land use? Okay. So what is the meaning of the term land use? What do we use land for in general? I'll start from the basic. What do we use land for? Maybe you'll say construction. Some of you will probably also say agriculture. What else do we use land for? We use land for many other things. We use it for let's say mining, etc. We use it for a lot of things. So this collective use of land for different purposes is termed as land use. If you'll see the textbook, the exact definition is given there. Land is used for different purposes such as agriculture, forestry, mining, building houses, roads, and setting up of industries. This is commonly termed as land use. So when you use land for, let's say, construction, agriculture, mining, and various other works, then that is termed as land use. So that is what land use is. What now? The second thing is, now that we've understood what land use is, what affects land use? And this is where the same concept of our topography kicks in. How can we use different pieces of land for different purposes? Or which piece of land, which type of land is most useful? Again, we'll go back to our example of plains versus mountains. Let's take our example of plains versus mountains. Which one do you think has more of a use? Well, let's list out. So, because of the smooth topography of plains, you can use it for agriculture. That's the first thing. Whereas in mountains, what can you do? Can you use it for agriculture? Can you use mountain areas for agriculture? No, you cannot. I'll tell you why. Because hills are like this. Now, they have an inclination. So if I were to place water here for my farming, if I were to put it here, let's say at this level, do you think it will stay there? It will not. It will flow down. And hence, a lot of water will be wasted and it will go towards the formation of rivers. So, using water in hilly areas is not possible. And hence, when you cannot use water, you cannot perform agriculture. Second, can you have construction? In plains, you can, because it's flat land and it enables me to draw up my plans such that it becomes easier for me to construct a house. But when we talk about mountains on the other hand, do you think I can build a home at this level? You cannot, because this is a very, very sharp tip, and if something happens, obviously the house will not stand, it will fall off. And that is the concept. Construction is not possible in mountains. The third point, is mining possible? Yes, in plains it is possible, because I only have to reach a small depth in order to mine minerals. Same concept as we used for population. Why do people don't settle? Is people don't settle in mountain areas because they have very less land use. As we saw here, you cannot perform agriculture, you cannot perform proper construction. I'm not denying the fact that you can perform agriculture and construction, but they are not traditional, they are not easy, they are very, very difficult. Final is, mining is not possible in hilly areas. Why? Because you have to dig very, very deep in order to find resources. So because there is very less land use in mountains, people usually settle for other landforms such as plains. So that is the concept of land use. How well can we use land and which areas use more land? Second is, how do we classify it? The third point that we look at is, how do we classify land? We can classify land into two categories. Land can either be private or it can be public. So, a land which belongs to a certain person, or a land that belongs to a certain group only, whose access is restricted. For example, our homes are the best example of private property. क्योंकि यहाँ पे हमने एक घर खरीदा है जहाँ पे सिर्फ हम रह रहे हैं. We cannot allow someone else to walk in. We cannot let them directly come in without our permission. That will be a breach of privacy, right? Why? Because we own that house as a group of people or as a single person. You own that house, and hence others cannot enter it without your consent. But when we talk about public land, on the other hand, it is not owned by a person or a group. Instead, it is usually government land. Usually the government owns this public land. For example, national parks, zoo parks. What else? What else are the government buildings? What else are the public available things? Think more for yourself, and if you can think of any more, yeah, these are the basic options that we have. So public property can sometimes also include any barren land as well, any barren plot that the government is willing to sell. So basically anything owned by the government comes under public land, whereas if a person owns it, it is called private land. Public land is also sometimes referred to as common use land. Why? Because everyone can use it. It is common use land because everyone can use it. You don't need a permit, you don't need permission to walk there and use it. It is common use. Everyone can use it. So that is the concept of private and common use land or public land. So if they ask you in the exam, identify private and public land from the given picture or from the given list of items, all you have to do is look for any government buildings. Usually in India, government buildings have the name Bhavan in their name. So if they have anything like this, then all of those come under common use land. Anyone can use them. On the other hand, if there is anything like, let's say, a common mistake people make is people think school is common use land. No, a school is not common use land. Every school has a chairman who owns that group of schools, right? So it is owned by a person or a board of people, and hence schools are not common use land, except when I say government schools. Government schools belong to the government and are government land, unless there are a few government schools in which the government gives out contracts to people to handle that school on the government's behalf. In that case, it can be common use land. So if it is, it cannot be common use land. Sorry. So if it is directly being handled by the government, then it is public or common use land. Basically, think of it this way: you can barge into that place whenever you want without paying any money or without taking anyone's permission. So all of that is common use land. So that is the concept of private and public land. Now, the final topic which we'll be covering when we talk about land is land conservation. You see, in the world, then what do you think happens to a population? Can a population grow? Can a population grow? Yes, it can. A population can grow. But what do you think? Can land grow? Can the amount of land grow? Absolutely not. Land cannot grow. Land is fixed on Earth because the amount of space available on Earth itself is fixed. So, when the amount of land is fixed, but the population can increase, more and more people will try to live on larger pieces of land, right? So that means that the amount of land available to us will decrease day by day. And that is the concept. We have to conserve or save land. We have to use it only for the most important of purposes. We cannot hoard large pieces of land. And that is the concept of land conservation. Because population, as I said, will always keep growing. Population cannot decrease. Population will always keep growing. With increasing population, it means there are more people living in the country. When there are more people living in the country, they will need more land. They need bigger houses. They'll need more farmland if they're working in villages. They'll basically need more land. And because of that, land is called a scarce factor. What is land called? The scarce factor of production. In class 9, you have this concept of factors of land production. उसमें हमें बताता है कि there are four factors of land production. Four factors of production: land, labor, capital, human capital. So land is one of those factors, but land is the scarce factor because land is limited. That is, it is not always available. It is only available at certain periods of time and only in certain places. So that is the concept of land conservation, that one should never hoard any amount of land only for themselves. They should use land only when necessary. So with that, we have finished the topic of land. So it was very simple. What did we look at? So first we looked at land versus soil. So what's the difference between both is what we looked at. Then the basic meaning of what land is. Okay, next we looked at a few more things about how land affects population. After which we looked at what do we mean by land use. After land use, what was the thing we looked at? We looked at the ownership of land, common use land, and common use or common property, as you can call it, and private owned land. Finally, we looked at conservation. How can we save land? So this is everything that we looked at when we were discussing land. Now remember the first point, soil. So what did we describe soil as when we were talking about the difference between land and soil? Soil, I'll write the heading here. Soil is the granular substance present on top of land. So that is basically what soil is. So when we talk about soil soil basically has a few factors. It has 5 factors of how it can be formed, how this granular substance is formed. These 5 factors, I'll draw a mind map for this. As I explained, I'll draw a mind map. The first is parent rock. What is a parent rock? Now you see, soil is not directly formed as it is. मतलब हमें ऐसे starting में it was not a grainy substance. Earlier, soil was in the form of rocks. Over time, these rocks, they broke and formed soil. What is this process of the breaking of rocks called? It's not breaking, but it's basically how it was a lump and slowly it started decomposing into small granular substance. This process of breaking up of stones in order to form soil is called the weathering of soil. So, through weathering, soil was formed. Now, what do I mean by parent rock? From which rock does the soil originate? When we talk about rocks, there are 3 types of rocks that we've discussed since grade 5. Sedimentary, metamorphic, and the other one which comes from volcanoes, which is igneous. So sedimentary, metamorphic and igneous rocks. Sedimentary is basically sediments. जो leftover sediments थे from rivers, they came and formed those rocks. Metamorphic is often a combination of 2 igneous or of 2 sedimentary rocks, and igneous rocks are basically those formed from volcanoes. So now because we have 3 types of rocks, the type of soil that we have depends on the parent rock. That is, from which of these following rocks was that specific soil formed. So we'll look at the types of soil in a bit and how they were formed, but this is the basic concept. The type of rock from which the soil was formed through the process of weathering affects the type of soil. So that is the concept of parent rock. The second thing is climate. So how does climate affect the formation of soil? Now you see, based on different climates, the parent rock weather at different paces. So based on the climate, for example, if I have igneous rocks, let's say, and if the temperature and the entire climate is humid and hot, then the rocks will weather at a faster pace. And because they weather at a faster pace, they're more likely to form a different type of soil. Apart from that, what is given in your textbook it doesn't have too much, but the second point in the textbook is that rainfall also influences weathering. So let's say there is a lot of rainfall, there is thick rainfall. Because of that, what will happen to the rocks? If there's thick and strong rainfall, then the rocks will break down very quick. The rocks are more likely to break down quick. And that in turn results in the formation of a different type of soil. So, climate includes both temperature and rainfall when we talk climate. So, the temperature causes a difference in the pace, a difference in how quick weathering happens, and same with rainfall. The heavier the rainfall, the faster the weathering. The third thing that we have to talk about is relief. So, what is relief? Now, relief is a little bit of a new term in 8th grade, so I'll try my best to explain it. Relief is basically the physical topology or topography of a place. Now, let's say something was formed in a hilly area. A rock was present in a hilly area and it weathered to form soil. Over there, over the course of a few years, the rock started sliding down the mountain and slowly it started to leave sediments behind. Because the rock was sliding, because of the friction of the ground, the friction caused the parent rock to break, and hence weathering happened. So when rocks are presented, and that weathering will happen at a different pace. So if So if my incline is, let's say, like this, if it's very, very steep, if my incline uh, if my incline is like this steep, versus if it's a little flatter, then the parent rock that falls at a different pace. Over here, the one on the left that you see, the parent rock falls at a faster pace. And as I told you when we were talking about climate, the pace of how quick the rock weathers often affects the type of soil that is formed, especially the texture of the soil. So that is what relief is: altitude and slope. Basically, the combination of altitude and slope is called relief in this context. Next, what we have to talk about is the natural life in that place. So I'll erase a little bit of this. I hope you understood parent rock. So the next thing is the natural life that was present there. Now, how does that affect anything? When we talk about natural life here, we are mainly talking about microbes or microorganisms. Now, if you've studied in biology, microorganisms decompose the soil that is present and hence adding fertility to the soil. और उस वजह से if there are a lot of microorganisms present in that area, then the soil is going to be more and more fertile. As we'll see, the type of soil tends to be more and more fertile. But for example, when we take a place where it is dry, where microorganisms cannot grow, then the soil will tend to be less and less fertile, because microorganisms decompose dead and decaying matter. If you've learned in biology, it converts that organic into inorganic substances for the use of plants in that particular area, and hence the soil is more fertile in such regions. So that is why the more the microbes, the better the soil, and hence the microbes change the way the soil's fertility acts. Finally, what I've been talking about for all this while, which comes as a separate category itself actually, is time. How quickly does a rock weather determines, as I said, when we were talking about both climate and relief, how quickly a rock weathers determines the texture of the soil. Will it be rough? Will it be smooth? Will it be very granular? All of that is determined by this time. That is, how quickly does weathering take place. So these are the 5 factors of soil formation. First is parent rock, where we have 3 types of soil, 3 types of rocks: sedimentary, igneous, and metamorphic. Next is climate, how rainfall and the temperature and humidity affect the formation of the soil. Next is relief, that how if the slope of an area is more, then the parent rock tends to fall down faster, and causing in a rough texture of the soil, causing in the change of the texture of the soil. So that is the concept of relief. Relief is basically slope and altitude combined. Next is the natural life over there. When we say natural life, we basically mean 2 things: microorganisms and plants. And finally is the ruling factor of everything else: time. How quickly does the parent rock weather tells us the texture of the soil. So those are the 5 factors of soil formation. The explanation that I gave here is for your knowledge. You need not write this in the exam because बहुत lengthy answer हो जाएगा. When they ask you, just give the explanation that is given in your textbook so that you can save on time for you. Okay. But everything I told now is important. It gives you an idea of how soil is formed. It gives you an idea of the overview of the concept. So next, what we talk about when we talk soils usually are the types of soils. Now this is very, very important. This is there in class 8 notes in a lot of schools, I believe, but is never mentioned explicitly in the textbook, and people hence face a lot of problem with this concept. So I'll be explaining 5 types of soils when we talk about types of soils. The first that I'll be talking about is alluvial. What is alluvial soil? When we discuss soil, we have to discuss a few things. The first thing that we discuss is the origin. Where does alluvial soil come from? It comes from the Himalayas. So in the Himalayas, there is a complex network of rivers that flows, rivers, the tributaries and the distributaries. So that way, when the rivers are flowing, they bring sediments and rocks with them along the way. And hence, all of these are deposited in a fertile land, in a fertile place called the delta. So I'll give a better explanation to you. Uh, I'll try to explain this in the best way possible of what a delta is. Usually, rivers do not flow alone. There are two concepts in rivers. There are tributaries which flow into the river and distributaries which flow away from the river, which are basically small parts of the river. Tributaries form the river, whereas distributaries leave the river. Now, when there is a complex network of rivers, the tributaries and the distributaries, then something of a triangular landmass is formed. So the tributary of this river, along with a new river and its tributary, and the main streamline of the river itself, forms this area called the delta. The soil found here is alluvial soil. This alluvial soil is the most fertile soil. Why? Think of it logically. Think of it logically. Why is it the most fertile? Do you notice something here? A delta or alluvial soil here is formed by three river or three water bodies, and in the center is alluvial soil or the delta. And because there is so much water present here, the soil's fertility gets enhanced. There is more and more fertility in the soil because there's more and more water, and when there's water, it becomes easy for farming, and hence the soil is fertile. So that is the concept of fertility of a delta and of alluvial soil. So the first type of soil that we talked about was alluvial. Where does it come from? It comes from the Himalayas. And how is it formed? It is formed by the deposition of sediments. Deposition of sediments by a river network. So alluvial soil is formed from the Himalayas, near the Himalayan region, and as I said, it is formed due to the deposition of sediments by a river network. Final is its fertility. It is highly fertile. Okay, so these are the three things that we talk about whenever we talk about a soil. The second soil that we find most in India is black soil. Black soil is also sometimes called as cotton soil. So when they say cotton soil or black soil, it's the same thing. So where is black soil found? In India, there are two major regions in which you find a lot of black soil. First of all, I want to cover why is it called cotton soil. Well, as simple as it is, black soil is important for the growth of cotton. So in India, where is it found? It is found in two places, mainly in Mumbai and Ahmedabad. Do you notice something? These two are the industrial cities of India where a lot of the textile manufacturing is done. Why is textile manufacturing done here? Because there's a lot of black soil here, which makes it easy for the growth of cotton and textiles. And hence, it is the textile region of India. Next thing, how is it formed? Well, it is again formed exactly like alluvial soil. It is formed just by the deposition, but this time of different types of rocks. And they are again formed near water bodies in deltas. And finally is they do not have too much of a high fertility, but not too less. But when we talk about for cotton, it is the best soil. For cotton, black soil is the best soil. You can't find any better soil than black soil, and hence it earns its name, cotton soil. So these are the two types that we've looked at so far, the alluvial and black soil. Okay, the next type of soil is red soil. Red soil is basically, I'm writing the short form, the Fe, that is iron, ferrum. So it is rich in iron. It gets its red color because of how rich it is in iron. However, in spite of having so much iron, it is not that fertile. And most important, it is usually found in the Deccan Plateau. So where I live in Hyderabad here, we mostly find this type of red soil, naturally forming. You can obviously buy it from other states, but red soil is the most common naturally occurring soil over here. It is often contemplated that it is the oldest type of soil as well, which is another concept in grade 9, which I'll not dive too deep into. So red soil, rich in iron, found usually in the Deccan Plateau, and it lacks fertility. The fourth soil that we'll be looking at is sandy or desert soil. As the name suggests, it is found in deserts. Okay. Next is, it is not at all fertile. It is not at all fertile, zero fertility. Why is that? Think of it. So, why is sandy soil less fertile? I'll tell you why. When you look at sand, as we've seen from younger grades, when we were talking about sand, water seeps in easily through sand. And because water seeps in, and because there is lack of retention capacity of sand, plants cannot grow. And because they cannot grow, a process called nitrogen fixation does not happen. So when plants do not grow, right? So it's kind of a self-fulfilling prophecy, let's call it. When you grow plants, soil receives nutrition through something called a nitrogen cycle, which is not important for you now. So when you grow plants, the plants, they gain fertility. But for plants to grow, you need fertility in turn. So because plants cannot grow here, this soil is not fertile. Why can plants not grow? Because it has less water retention capacity. And without water in the soil, plants cannot survive. And so that is the concept of sandy soils. Now, the final type of soil that we have to talk about is mountain soil. What is mountain soil? Well, as the name suggests, it is found in mountains, obviously, and it also lacks fertility. Now, keep in mind that mountain soil is different from alluvial soil. If this is my Himalayan ranges, let's say, then the soil found over here, let me use, do I have a different color? I don't think so. Anyway, so the soil that is found over here is mountain soil. But from here, let's say there's a river flowing. And the soil found around here, somewhere, let's say, near the river, is alluvial soil. So alluvial soil is found downstream, whereas mountain soil is found upstream. So that's the difference. And so mountain soil lacks fertility. क्योंकि यहाँ पे ज़्यादा पानी नहीं है. Same concept with sandy soils, that water cannot stay on hills. If this is my hill and this is my slope, if I try to put water here, will it stay? It won't. It will flow down, and that forms rivers. So that is the concept, because hilly areas cannot have too much water, plants cannot grow, and if plants cannot grow, soil does not receive fertility through nitrogen fixation, and hence the soil lacks fertility. So that is the concept of types of soils. Now, the final and most important concept in the entire part when we talk about soils is the conservation measures or the conservation techniques. How do we save soil? So here they have given to us, I think, 7. Yes, they've given us 7 measures to save soil. So let's see what they are. The first thing is mulching. What do we mean by mulching? Write the ing as well. Mulching. Let's say this is my soil. If I cover this soil with hay or straw, let's say, then that process is called mulching. Why is it done? Because if the soil lacks water retention capacity, then this mulching provides water retention capacity to it. Because things like straw, which are dry in nature, have a lot of capacity to hold water. And so if water is provided, then they hold on to the water for a while. They hold on to the water and slowly let it drip through the soil. So that way, no water is wasted and all the water is slowly provided to the growing plants. So that is the concept of mulching. When you add a layer of, let's say, hay or dried stalks. Now, the second concept is contour barriers. What are contour barriers? Well, first of all, what even is a contour? So let's say this is my hill. Then the different lines at the same altitude, let's say, all of these are present at the same altitude. Let's say 30 meters and 90 meters. 90, 30. All of these lines present at the same altitude are called contours. These are imaginary lines. They're not present on mountains. So people often draw these imaginary contours in order to measure the length of the mountain or for certain things. So these contours are imaginary straight lines on mountains. So when you build barriers exactly parallel to these contours, when you build barriers parallel to these lines, that is called a contour barrier. So if I build my barriers like this, that is called a contour barrier. What does a contour barrier help in? So if my water is coming from upstream, from over here, and it flows because of a gap, let's say here, it flows here. If these contours were not present, and if the contour barriers were not present, and it was a normal landmass, then the river would flow, and it will flow something like this, right? And it will erode all of the soil present here. All of the soil present here will be gone. It will be taken downstream, it will be taken somewhere else, but it will not be present here. And so a lot of soil gets wasted in this process of soil erosion. But if this is my contour, and if I build barriers parallel to it, and I dig a few holes here, okay, let's say these are my holes and I'm digging a few holes here. If water comes here downstream, then all of the water is collected here. Let's say if the force of the water is so high that it does not get collected here, then it is stopped by the barriers. Or if in case there is some soil along with this water, let's say soil also comes down, then that soil as well is stopped by these contour barriers while the water goes in. So that is the concept of a contour barrier, building barriers parallel to the contours. What is a contour? It's basically that imaginary line at the same altitude of a mountain that we draw. It is imaginary. It does not exist in real life. We just imagine it to be that way. So the third thing that we have to talk about is a rock dam. A rock dam, they're pretty simple, right? So if you have a river coming if this is my river, then I'll build a huge wall over here, which I'll open only when I need this water to flow. And so that prevents the water from going into soil rich areas. If this is my soil here, it prevents the water from coming here. If the water ends up coming here without this stoppage, just like we saw in contour barriers, the soil will be eroded and taken further downstream. And we don't want that to happen because a lot of soil gets wasted, and we want to conserve soil. So uh, by building rock dams exactly ahead of, let's say, alluvial soil deltas, we can conserve a lot of fertile, rich soil. Next thing that we have to talk about is terrace farming. Terrace farming is another interesting thing. So if this is your hill, then can you actually farm here? You cannot. As I've quoted the example multiple times, if I put water here, the water will come flowing down directly. But what if you build, you you make slight cuts in the mountain, you dig a little and modify the shape of the mountain. So that way you have a structure of something of this sort with you. Here you can grow your crops. And so, why can you grow it? Because all of this turns into flat land. And so if my water comes from up here, it will settle down here. Hence, making it essential for farming. And hence, we can save a lot of soil, because if the water doesn't go downstream, it does not take a lot of soil with it downstream. It is being stopped here directly. And hence, we can conserve a lot of soil that way. And we can also perform farming in hilly areas. The next thing is intercropping. Now, remember when we talked about how land was a scarce and limited factor? Well, such is the case with soil. There is only a limited amount of soil on earth, and hence it is important to conserve it, right? So how are you going to do it? You are going to grow multiple crops on the same land. The land is the same, but if earlier I was growing corn, then along with corn I'll grow peas. So in a certain combination, when you grow multiple crops on the same land, on the same soil, you're saving a lot of soil. And hence, yeah, that achieves our objective, right? Saving soil. So after intercropping, the next thing is contour plowing. So when we look at the hill here, as I said, these are our contours, imaginary lines that we draw. We saw that if we build any sort of blockings, or if we build any sort of barriers, that is called contour barriers. But what if I were to do a little bit of digging here instead? Instead of building barriers here, I'll do little bit of irregular plowing and digging, and that will create space for the water to flow in. If water flows from here, it will go here, some of it will go here. If the stream is very strong, then it'll even reach this. So that is called contour plowing, when you make some space in the land for water to come in parallel to the contour lines. What are the contour lines? They are these imaginary lines that we've drawn in mountains. Finally is shelter belts. Now think of coastal areas. If this is the coastal land, then everything over here, let's say, is water. So there's a high chance that the water comes flowing here, and and there's a high chance of flood, and hence the soil might be wasted because of the flood and soil erosion. So what they usually do is they plant tall palm trees. They plant tall trees here such that they stop the water in turn. So the water that comes here is stopped naturally by these trees, and that is called shelter belts. And so, with understanding the concept of shelter belts, we've finally finished the first part of the second chapter. So, I hope you understood the concept And I'll be continuing this chapter in the next video in geography, in which I'll be talking about water, and I'll also be talking about vegetation and natural wildlife. So I'll see you in that video. Thank you. So if you enjoyed the video, then please make sure to like and subscribe and click the bell icon to remain notified. If you know someone who is interested in videos like these, then please do share these videos with them. And I'll see you in the next one.